800 million users on a single PostgreSQL primary, and OpenAI says that's actually working?
Wait, they're running ChatGPT on one primary database? How's that even possible?
So we're breaking down their optimizations, the single primary architecture risks, and how they handle failover.
By minute 4, you'll know their exact query optimization playbook. Let's get into it. Welcome to the Platform Engineering Playbook Daily Podcast. Today's news and a deep dive to help you stay ahead in platform engineering.
Today, we're diving into scaling PostgreSQL to power 800 million ChatGPT users.
Stick around to the end for this week's headlines. Let's dive right in.
So, OpenAI just dropped some fascinating details about how they scaled PostgreSQL to handle 800 million ChatGPT users. And Alex, this is one of those stories that makes you rethink everything we thought we knew about database selection at Hyperscale.
Right, because conventional wisdom would say at that scale, you'd need something like Oracle or maybe even a custom solution. PostgreSQL handling 800 million users? That's massive.
It really is. And what's particularly interesting here is the timeline. We're talking about going from 0 to 800 million users in under 2 years. That's not just growth, that's explosive, unprecedented growth that would break most systems.
The operational challenges alone must have been insane. I mean, most companies plan their database architecture for maybe 10x growth over several years. This is what, thousands of times growth?
Exactly. And here's what makes this even more remarkable. They didn't just scale the user count. Think about what ChatGPT does. Every conversation is stored, every interaction logged, context maintained across sessions. We're talking about potentially billions of database operations per day.
So why PostgreSQL? I mean, there had to be a moment early on where they're sitting in a room deciding between Postgres, MySQL, maybe MongoDB for the document storage aspects, or going with an enterprise solution.
Well, there are a few factors that probably played into this. First, PostgreSQL has incredibly robust JSON support, which is crucial for storing conversation data. But more importantly, it's the extensibility. When you're building something that's never been built before, you need a database you can modify and extend.
That's a good point. With Oracle or SQL Server, you're kind of locked into their way of doing things. If you need a custom extension or a specific optimization, you're waiting for the vendor.
Exactly. And cost is another huge factor. At 800 million users, even a small per-user licensing fee becomes astronomical. We're potentially talking about hundreds of millions in database licensing alone.
But surely at that scale, the operational complexity of managing PostgreSQL yourself versus having enterprise support would eat up those savings.
That's the interesting trade-off, isn't it? OpenAI clearly decided that having full control over their database layer was worth the operational overhead. And when you think about it, at their scale, they probably have database expertise that rivals any vendor support team.
What about the technical challenges, though? I mean, PostgreSQL is great, but 800 million users, that's got to be pushing the boundaries of what's possible with a traditional relational database.
Oh, absolutely. And I think that's where this story gets really interesting for platform engineers. This isn't just about choosing PostgreSQL and calling it a day. This is about how you architect around PostgreSQL's limitations while leveraging its strengths.
Right, like sharding strategies, read replicas, caching layers.
Exactly. And connection pooling becomes absolutely critical at this scale. PostgreSQL's process per connection model means you can't just throw connections at it indefinitely.
Coming up, we'll dig into exactly how they pulled this off, the specific architectural patterns, the operational practices, and what this means for the rest of us trying to build scalable systems.
So let's dive into the technical architecture here. Based on what OpenAI has shared and what we can infer from PostgreSQL's capabilities at scale, they're likely running a pretty sophisticated setup.
Walk me through what you think their architecture looks like, because 800 million users isn't something you handle with a single PostgreSQL instance, right?
Definitely not. They're almost certainly using horizontal sharding, probably sharding by user ID or conversation ID. Each shard would be its own PostgreSQL cluster with primary replica setups for high availability.
That makes sense. And with PostgreSQL 15 and 16's improvements to logical replication, managing those shards becomes a lot more feasible. But what about the write load? Every message in ChatGPT needs to be persisted.
This is where it gets interesting. They're probably using a combination of strategies. First, asynchronous writes where possible. Not every operation needs to be immediately consistent. User preferences, settings, that kind of thing can lag a bit.
But conversation history needs to be consistent, right? Users expect to see their chat history immediately.
True, but even there you can be clever. Write to a fast cache layer first, Redis or similar, then batch write to PostgreSQL. As long as your cache is durable enough, you can smooth out the write spikes.
That adds complexity, though. Now you're managing cache invalidation at massive scale.
Absolutely, but that's the trade-off. And speaking of trade-offs, let's talk about what PostgreSQL gives you that makes this complexity worth it. First, the JSON-B support is incredible for storing conversation data. You get the flexibility of document storage with the ACID guarantees of a relational database.
Plus, PostgreSQL's full text search capabilities. For searching through conversation history, that's got to be huge.
Exactly. And here's a specific example. PostgreSQL's GIN indexes on JSON-B fields. These let you index into JSON documents efficiently. So when a user searches their chat history, you're not doing a full table scan across millions of conversations.
What about connection pooling? You mentioned that earlier. At 800 million users, even if only 1% are active concurrently, that's 8 million potential connections.
Right, so they're definitely using something like PG Bouncer or PG Pool 2, probably PG Bouncer given its lower overhead. You'd configure it in transaction pooling mode to maximize connection reuse, maybe 50 to 100 actual PostgreSQL connections per database, serving thousands of application connections.
And monitoring? How do you even monitor PostgreSQL at this scale?
That's crucial. They're probably using a combination of native PostgreSQL stats, custom exporters for Prometheus, and likely have built significant custom tooling. Things like query performance, replication lag, connection pool efficiency, all of that needs real-time monitoring.
What about backup and disaster recovery? At this scale, even backing up the data becomes a challenge.
PostgreSQL's incremental backup capabilities help here. Tools like PG Backrest or Barman can handle continuous archiving. But at their scale, they're probably also using logical replication to maintain hot standby regions. If US East 1 goes down, they can fail over to US West 2 with minimal data loss.
The operational overhead of all this must be significant. We're talking about a full team just managing the database layer.
But here's the thing. Compare that to the alternative. Enterprise database licenses for 800 million users, we're talking hundreds of millions per year. That buys a lot of engineering talent. Plus, with PostgreSQL, they can modify the source code if needed. Try doing that with Oracle.
Are there specific PostgreSQL features that make this scale possible that wouldn't exist in other databases?
Several, actually. PostgreSQL's table partitioning improvements in recent versions are huge for managing large tables. The ability to partition by range or hash with automatic routing of queries to the right partition. That's essential for managing conversation history at scale.
And parallel query execution? PostgreSQL can split large queries across multiple CPU cores.
Exactly. Plus PostgreSQL's extension ecosystem. Things like timescale DB for time series data, PostGIS if they need geographic queries, PG stat statements for query analysis. The ecosystem is incredibly rich.
But what about the limitations? There must be things PostgreSQL doesn't do well at this scale.
Oh, absolutely. Cross-shard queries are complex and slow. PostgreSQL's vacuum process can be problematic on very large tables. And while recent versions have improved, historically PostgreSQL's replication has been more complex than MySQL's.
Stick around. In our final segment, we'll break down the exact playbook for scaling PostgreSQL, what platform engineers can learn from OpenAI's approach, and the key decisions you need to make if you're considering PostgreSQL for your own high-scale applications.
All right, so let's talk about what platform engineers can actually take away from OpenAI's PostgreSQL scaling journey. Because while most of us aren't building the next ChatGPT, the principles here apply broadly.
Yeah, I'm thinking about teams that are maybe at 10 million users, wondering if they should stick with PostgreSQL or migrate to something else. What's the decision framework here?
First key takeaway, PostgreSQL can scale much further than most people think, but it requires expertise and investment. If OpenAI can handle 800 million users, your 10 or even 100 million user application is definitely feasible. The question is whether you have the team and architecture to support it.
So, what's the checklist? If I'm a platform engineer evaluating PostgreSQL for scale, what should I be looking at?
Start with your data model. PostgreSQL excels when you need ACID compliance, complex queries, and flexible data types like JSON. If you're just doing key value lookups, you might be better off with something else. But if you need real relational capabilities plus document storage, PostgreSQL is hard to beat.
What about the operational side? What capabilities does a team need?
Critical skills include deep understanding of PostgreSQL internals, how vacuum works, how it tunes shared buffers and work mem, how to analyze query plans. You need expertise in replication strategies, backup and recovery, and connection pooling. And you absolutely need strong monitoring and automation.
That's a pretty specialized skill set. Not every team has a PostgreSQL expert.
True, but here's the thing. PostgreSQL has incredible documentation and community support. The learning resources are there. And compared to proprietary databases, you can actually understand what's happening under the hood. When something goes wrong at 3 a.m., being able to read the source code is invaluable.
Let's get specific. What architectural patterns should teams adopt from day one if they're planning to scale?
First, design for sharding from the start, even if you don't need it yet. Choose a sharding key that distributes load evenly. User ID is common, but think about your access patterns. Second, implement connection pooling early. PG Bouncer is lightweight and battle-tested. Third, separate your read and write workloads. Use read replicas aggressively.
What about schema design? Any PostgreSQL-specific considerations?
Absolutely. Use JSON-B for flexible data, but don't overuse it. It's tempting to throw everything into JSON columns, but you lose query performance and data integrity. Also, leverage PostgreSQL's table partitioning for time series data. If you're storing events or logs, partition by date from day one.
And monitoring. What metrics matter most?
Connection pool efficiency is critical. Monitor active versus idle connections. Watch your replication lag closely. Track slow queries religiously using PG stat statements. And monitor vacuum performance. If vacuum can't keep up, your database will eventually grind to a halt.
What about the build versus buy decision? When does it make sense to go with managed PostgreSQL services like RDS or Cloud SQL versus running your own?
Great question. Managed services are excellent up to a certain scale. They handle backups, updates, basic monitoring. But at OpenAI's scale, the lack of control becomes limiting. You can't modify kernel parameters, can't use certain extensions, can't optimize for your specific workload. I'd say stay managed as long as possible, but be ready to migrate when you hit those limits.
Looking forward, what developments in PostgreSQL should platform engineers be watching?
PostgreSQL 17 is bringing improvements to parallel query execution and vacuum performance. The work on distributed PostgreSQL, projects like Citus and YugabyteDB, is fascinating. And the ecosystem keeps growing. Tools like Supabase are making PostgreSQL more accessible for modern applications.
So the meta lesson here is that open source databases have really matured. The idea that you need Oracle or SQL Server for serious applications feels outdated.
Exactly. And here's my provocative take. In 2024, choosing a proprietary database for a new project is usually a mistake. The open source options are not just good enough, they're often better. more flexible, more transparent, better community support, and no vendor lock-in.
But there must be cases where proprietary still makes sense.
Sure, if you have deep expertise in a proprietary system or specific features you absolutely need, but those cases are increasingly rare. The innovation is happening in open source. PostgreSQL, MySQL, ClickHouse for analytics, Redis for caching. The open source ecosystem is incredibly rich.
And the cost savings can fund a lot of engineering effort to make open source work for you.
That's the key insight. OpenAI probably saves tens of millions per year on database licensing. That funds a world-class database team who not only keep the system running, but contribute improvements back to PostgreSQL. It's a virtuous cycle.
So, for platform engineers listening, the message is clear. Don't underestimate PostgreSQL. With the right architecture and expertise, it can scale far beyond what most of us will ever need. And the skills you develop are transferable and valuable.
Exactly. The future of infrastructure is open source, and PostgreSQL is leading the way in showing what's possible when great engineering meets community-driven development. Before we wrap up, let's catch up on this week's infrastructure news. There's a fascinating, comprehensive guide making waves in the infrastructure as code space. The folks at Env0 have published an extensive breakdown of IAC tools and Terraform alternatives that's getting a lot of attention from platform teams.
Oh, this is timely. I've been seeing more teams evaluate their IAC options lately. What tools are they highlighting?
They cover the usual suspects like Terraform and OpenTofu, but also dive into Pulumi, Crossplane, and even configuration management tools like Ansible, Salt, Chef, and Puppet. What's interesting is how they position each tool's strengths for different use cases.
Makes sense. With OpenTofu gaining momentum and tools like Crossplane bringing Kubernetes native approaches, teams really need this kind of comparison. Speaking of Kubernetes at scale, Northrop Grumman just shared their journey of standardizing on Red Hat OpenShift across their enterprise. They faced major challenges scaling Kubernetes back in 2020.
Northrop Grumman? That's a massive enterprise deployment. What drove them to OpenShift?
According to Red Hat's blog, they needed a modern, multi-cloud Kubernetes platform that could handle their AI and hybrid cloud workloads. The standardization helped them overcome their scaling challenges. Now, here's a controversial one. A developer on dev.to claims they replaced Redis with PostgreSQL M and actually got better performance.
Wait, what? That goes against conventional wisdom. Redis is purpose-built for caching.
That's what makes it interesting. The author walks through their specific use case and implementation details. It's a reminder that sometimes the obvious choice isn't always the best for your particular situation.
True. And speaking of evolving technology landscapes, Chris Aniszczyk from the CNCF gave an interview to the News Stack about AI interoperability efforts.
The CNCF is getting into AI standards?
He's drawing parallels between AI agents and microservices, suggesting the CNCF can extend their conformance programs to ensure AI interoperability. It's a natural evolution of their cloud-native mission.
That makes sense. If AI workloads are going to run on Kubernetes, we need standards.
And finally, the OpenTelemetry eBPF instrumentation SIG has announced their 2026 roadmap. They're targeting a 1.0 production-ready release.
eBPF instrumentation hitting 1.0? That's huge for observability. What are their main goals?
They're focusing on expanding protocol and language support, plus improving integration with the broader OpenTelemetry ecosystem. This could really change how we approach zero-code instrumentation.
The observability space just keeps getting more powerful. That wraps up this week's news.
That's our show for today.
If you found this valuable, please subscribe and share with a friend who'd appreciate it.
Drop us a comment with your thoughts on today's topic.
Links to everything we discussed are in the show notes.
And check out platform-engineering-playbook.com for more resources and guides. Until next time.